Welcome back to my Commodore 64 Memories videos. This is where I look at old Commodore 64 software and some of the technical details behind them. Today we have the X-File, a demo recently released, and this certain part of the demo claims to be showing 11 sprites. So we'll first of all have a look at this in HOX, and then we'll see what it looks like in C64 debug GUI and also Vice with ICU64. So you notice that the top border sprites drop down onto the bottom border sprites, which are a horizontal sprite scroll, and up at the top, yes indeed, we have what apparently looks like 11 sprites. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 sprites. And they move around as well, and they expand and contract horizontally. So this is quite special and nice looking, isn't it? Let's get into it. Okay, here we are in C64 debug GUI. I think this is going to show pretty much quite easily what's going on in the top and bottom borders with its cycle accurate display of VIC registers. But we'll just check. I'm just saving a snapshot because I want to get back to this point in the demo later on quite quickly. So we have this, it was a very fast scrolling bitmap screen, but if you saw my previous video on fast bitmap scrolling, then you would know how that one was done. But we're not going to have a look at that, we're actually having a look at this part. So we can turn on and off the layers for the C64 sprites and stuff like that in this C64 debug GUI. That might be useful later on if we can see what sprites are what, but we can see down at the bottom border straight away that we have what looks like a mixture of variously horizontally positioned sprites or horizontally expanded sprites. I think they're at different positions horizontally. So the bottom border has this what looks like a high resolution character scroll, but it's in the border. And we can see here in this zoomed in debug view that we have sprites in the bottom border, but we have what looks like high resolution pixels and with a color graduated fill in background. Of course, that's going to be the background screen color, right? But we have the sprites up in the top border and then they drop down into the bottom border like this. Now, normally you shouldn't be able to have a high resolution sprites, even with expansion, having an extra bunch of sprites over the top, dropping over them, because that would violate the 8 sprite horizontal line limit. So obviously there's some sprite merging going on, I think, from the sprites which drop down from the top down to the bottom. We can see immediately that it's just a normal bitmap screen with bad lines and everything else. We can see that the sprites actually start displaying above the border up at the top, or at least they're positioned to start kind of displaying. And you want that if you're going to have sprites dropping down into the bottom border, right? You want to be able to have the sprite date. And then we have this area of the screen where the supposedly high resolution text is scrolling across, but it's not text mode. It's done with sprites, obviously, because it has to be, because it's in the bottom border. And we can start seeing immediately that we have another bunch of sprites underneath that as well, which is positioned for the lower part of the X-File logo. The part that's in the cyan bordered sprites there in the bottom border. But just above those, we have a whole bunch of high resolution sprites which are horizontally expanded. Almost always. So if we notice here with the targeting cursor, as I move it up, we start seeing that we have these differently positioned horizontally expanded sprites, and then it starts shifting them down in preparation for the area just underneath the horizontally scrolling message. And we can also see that there's quite a lot of updates going on in terms of standard and multicolor updates at specific vertical positions on the screen in the columns. As I move that targeting cursor horizontally across the raster line, the standard multicolored mode for each of the sprites was changing. Let's turn on force coloring. So in the debug view, we can switch on force coloring so we can actually see what is sprite data. And we can immediately see that the first X sprite on the left-hand side is a normal sprite. But we can see that the rest of the sprites on this particular point on the scan line anyway have like inverted colors. So the transparent part shows the screen color behind, and the opaque part of the sprite in these sprites anyway, for the sprites 1 to 7, not sprite 0, the opaque part is actually colored in white now, but it was colored in black. So it's kind of like pretending to be the border with opaque parts of the sprite data, with the transparent portion showing the border color, or the screen color rather, sorry, behind. So I'm going to move the targeting cursor for the raster schedule left and right, and notice that these sprites are rapidly changing between standard and multicolor mode. These store X, store A, store X's to D01C is what changes the VIC register to say render these sprites as multicolor mode or high res mode. But don't forget that they're horizontally expanded in the X. We can see that in the register dump there as well. So these portions, so when the CPU is storing into the VIC register, there's a cycle schedule for the store A, store X instruction. And at this particular point in the cycle schedule for these instructions, for the store absolute instructions, the value goes into the VIC register just as these vertical portions, or the horizontal portions, the multicolor portions of the sprites are going to be finished displaying. So the sprite is set up to be multicolor when it has to be multicolor for displaying the sprite data, and then the sprite is switched off like 4 pixels into it displaying the sprite. So because it's one register write to set up the multicolor state for all of these sprites, it's possible for the CPU, precisely timed in the raster scanline schedule, to switch off multicolor mode, say 4 high resolution pixels, or 2 multicolor pixels, or basically 1 horizontally expanded, X expanded multicolor pixel, right, into the particular precise vertical position on the screen, so that the rest of the sprite data is displayed as horizontally expanded high resolution sprites. But we've had the time to display, say for example, the vertical portion of the F, or the vertical portion of the I, or the L, or the horizontal portion of the L and the E. We can see that the first sprite is actually bouncing up and down, not because its position changes, but because the sprite pointer changes as well. There are 2 ways of doing that bounce, well 3. You can move the sprite vertically, but that changes the raster timing schedule, and you probably don't want to do that. You want to have nice consistent raster timing schedules. The second way of doing it is to update the sprite data itself in memory, which is quite a lot of work. Or the third way is to have pre-calculated sprite frames. So that X bouncing up and down is using pre-calculated sprite frames. It's the same for the sprite frames for the bottom letters as well. The sprites in the bottom border are not changing their vertical position. It's the actual sprite frames for the L and the I and the E bouncing up and down. You can see there, look, the sprite pointer changes as different E's and I's and F variations are displayed at this point on the screen. So when we have a look at this in Vice plus ICU64, we'll be able to see, I expect, these pre-calculated sprite frames in memory quite easily. And I'm really glad actually that this version of C64 debug GUI is able to display this demo effect quite cleanly. I don't see any major artifacts or problems with the rendering of this. Even though this version of C64 debug GUI is quite old, it's still able to render these effects. So that tells us, right, that this effect is not some unknown VIC trick or anything else, or a new Vic trick. It's just basically a nice, clever implementation of an already found Vic chip trick, which is, quite relatively properly emulated. So I think what we should probably check is the ghost byte, right? Because the ghost byte is kind of integral, I think, to this demo effect. So if you don't know, when you open the borders, especially the top and bottom borders, the Vic chip will display what's called like a ghost byte or an idle byte. Usually it's the byte. In standard kind of like screen modes anyway, it's usually the byte which is right at the end of the current Vic bank which is being displayed. So in this case, it's going to be 3FFF. So the thing is, with high-res horizontally expanded sprites being used for the scroll down at the bottom, which is not text, it's made up of sprites, but it looks like text, right? Usually, because you have high-res sprites which are horizontally expanded, then the pixels are going to look like multicolor pixels, or they'll be doubled in size horizontally, right? But what you can do is that if you're really, really clever, you can update the ghost byte, which can display either transparent or black, basically. And so you can, if you're really clever, look, use, and I can see the store A with 3FFF there being precisely timed as well, and it's changing, which is also a good indicator that it's really being used here. So the memory debug view shows the location is being written to in red very often. The code is writing to that memory location very often. And the thing is that it's basically inputting pixel patterns into the ghost byte, which get repeated in the background, in the transparent areas of the sprite, which kind of like with the screen color shining through, right? There are some extra little twiddly high-resolution pixels being added by updating the ghost byte to give what looks like, apparently, high-resolution pixels in a horizontally expanded high-res sprite, which gives the kind of like, it kind of like gives a very good kind of like trick, if you like, of making it look like there are high-resolution characters or high-resolution sprite data being moved around when actually it's not. It's just extra definition, if you like, extra pixels of high resolution definition being inserted by using the ghost byte. I think what I should probably do is that I should disable the ghost byte update code, and then we can see what effect disabling the ghost byte has on the visual output of this demo. So I'm going to do that a bit later on, I think. But I really do like the precise timing needed to switch the sprite from multicolor mode to high-res mode at a particular point on the screen. And now the sprites are precisely positioned horizontally so that when the Vic chip kind of like slices vertically the sprite from multicolor to high-res mode, it's kind of like precisely timed, and with the sprite positioning, it gives you this nice kind of like narrow band rather than the standard 8 pixels in high-res pixel terms for each cycle. It's kind of like half of that, right? So it makes it look like it's apparently high-resolution sprites or multicolor sprites over the top, when actually it's not. It's just precisely timed changes from multicolor to single to high resolution color mode for the sprites. So before going into ICU64 and Vice, let's just use this session of C64 Debug GUI to look at the sprite in the top border, when apparently there are these 11 in inverted commas sprites being displayed up in the top border. Now, if you recall from my previous video about the demo 9, which showed 9 apparent sprites in inverted commas in the top order, that was using ghost byte shine through and horizontally expanded sprites for a couple of sprites, right? And my 10 demo, which displayed 10 apparent sprites up in the top border, also used ghost byte shine through. This demo doesn't use ghost byte shine through in the top border. It's just using, surprisingly, just normal sprites. These sprites, I mean, the letters look high resolution, right? But we can see from their bounding boxes, their red bounding boxes, not all of them are high resolution, but they still look apparently high resolution in this debug mode. And I'm advancing the frame, or trying to go frame by frame anyway, in this C64 debugger. And we can see, look, the O and the C, the A and the V, and the T and the E look like they're horizontally expanded sprites, but they look high res. And the sprite is changing halfway, changing color halfway. So I think there's some precise timing going on here. We'll have a look at that in the raster line schedule, just in a second or so. But we can also see where the non-expanded sprites are, right? We can see from their bounding boxes that there are more non-expanded sprites, and then there are, 1, 2, 3 horizontally expanded sprites. So when we have all of these letters together, then it's 11 letters. But we know now, obviously, that, oh, well, there we go. That makes it really obvious. The sprite frames, we can see that O and C are grouped together. A and V are grouped together in another sprite. And T and E are also grouped together. When I step the frames, you can see, look, that these sprites, which are, they look like individual sprites on the screen, but when you look at them in terms of their sprite pointer, you can see actually that the sprite pointers are changing. So these are all pre-calculated. Let's turn off the sprite forcing color. There we go. We can see now, look, that the T and the E, the A and the V, they're all using pre-calculated sprite frames with different horizontal positioning between the T and the E. And we can see there straight away on the targeting cursor, look, that the sprite on the sprite cycle to the left, it's white, and then on the sprite cycle to the right, it's yellow, or vice versa, right? And here we can see, look, the sprite colors are changing at specific cycles in the scanline schedule, and so we've just got some precisely timed code. This precisely timed code precisely updates the sprite color in the middle of the horizontally expanded sprites. Now let's zoom in. I'm going to make it really easier to see, hopefully. If I zoom in here with the magnifying glass, pay attention to the X position of the sprite as I move the targeting cursor up and down. The X position of each of these pretend high resolution sprites, but they're not, they're expanded sprites, right? Okay, this magnifying window is a little bit annoying, but yeah, the X position for the sprites changes on different raster lines. So if we have horizontally expanded high resolution sprites, and the pixels will appear like they're doubled up horizontally, right? But then if on different raster lines, different horizontal pixel positions are used, then we get what look like apparently higher resolution pixels in the horizontally expanded sprites, because the pixels are going to be at one horizontal pixel position, and then on the next raster line they'll be shifted left or right by 1 pixel, or they can be. And so we get this apparently higher resolution sprite information being rendered on the screen when using horizontally expanded sprites. So the timing for the top portion of this demo is actually it's cycle exact timing, but there's actually not much going on more than, say, for example, in the 9 demo or in my 10 demo, which was showing 10 apparently high resolution sprites. So there's actually not much different, right? I mean, the timing is precise, but it's using pretty standard effects. It's just using pretty standard effects rather well to trick the viewer into thinking that there's more sprites when there's not. However, honestly speaking, I don't think this demo is quite as technically capable as the 9 demo for one very good reason, and that's because the 9 demo tried to make a very persistent point that each of the individual 9 sprites, in inverted commas, was colored or had consistent coloring. The 11 sprites, in inverted commas, up in the top border, don't always have consistent coloring. And that means that it's actually easier. I mean, the 9 demo, because it had, what looked like consistently colored 9 sprites, it created a much better illusion of rendering more than 8 sprites in a horizontal band. So anyway, we'll get onto that in a little bit, I think, but I wanted to go back to the Ghost Byte update. So I'm going to try and switch off the Ghost Byte update by altering the memory here. So instead of storing it in 3FFF, I'm going to be storing the Ghost Byte updates into 3FFE. So it doesn't change the overall timing of the raster line schedule for this demo, but what it does do is that it stores what should be the Ghost Byte into somewhere where it's not a Ghost Byte. It's just the second to last pixel in some character set somewhere, or some memory location somewhere, or some sprite somewhere, 1 byte prior to the Ghost Byte in the same Vic bank. I'm just doing the minimal amount of code change here. I'm just looking through the memory dump for all occurrences of FE or FF3F, and hopefully that's going to be all of the stores, the store A and the store X instructions with the absolute variant, absolute address meaning the 16-bit address. So let's go through, just see if I can find all of them by I power. I'm just quickly moving to Vice in ICU64 so I can do a watch. Actually, no, I'm going to do a hunt. I'm going to hunt for all of the store instructions and hopefully find them all that way. So this is the store accumulator variant of the instructions. So that's 8DFF3F. It's A730. So I'm going to be changing A731 to FE. And then A74F plus 1 is A750 to FE, so on and so forth. It's easier to hunt for the instructions in the machine code monitor in ICU64 Vice version rather than trying to do it in C64 debug GUI. I think that's the last store A variant. I'm going to take a screenshot of the bottom part of the screen here so we can compare it. Okay, it's the comparison which is the important thing, because then you see the benefit in visual terms of what the Ghost Byte does for the expanded sprite scroller in the bottom border. So let's delete all of those breakpoints. Let's go back, and we put a watch store point in there as well for 3FFF. Okay, cool. I think that's found all of them, right? Let's change the Ghost Byte now so that the Ghost Byte is cleared out. There we go. I can see the change immediately, but I'm going to take another screenshot and I'm going to zoom in and we can put them side by side for easier comparison, right? So let's edit that one in Paint as well. Where has it gone? Okay, so this is the one with no Ghost Byte update. So the Ghost Byte is not being updated and the Ghost Byte has just been set to completely transparent, okay? So there are no black pixels from the Ghost Byte. And then let's put the original demo's version next to it, okay? That should be a bit more obvious. Let's zoom in a few levels. And let's zoom in a few levels on the updated version. So the original version on the left with high-res Ghost Byte compared to the version on the right. And the version on the right, you can see it looks kind of like blobby, right? And horizontally expanded. That's what you would normally see with a horizontally expanded sprite scroller. But with the Ghost Byte, we got those extra high resolution pixels. And I think we'll be able to see that now in C64 debug GUI as well. So I think I've managed to find all of the Ghost Byte updates in C64 debug GUI. So I'm just checking the raster line schedule and I'm looking at the code view on the left. Without much surprise, right, the Ghost Bytes are only being updated during the portion of the supposedly high-resolution text. And I don't think that the Ghost Byte is actually being updated every single raster line. It's only probably being updated on important lines when there are changes needed for the extra apparently high resolution pixel tweak, right? So here we go, there we go, we can see it now. once it's executed a frame, we can see straight away, look in this C64 debug GUI version now, that the horizontally expanded sprite data, it's no longer, there aren't any high resolution pixels anymore because the ghost byte has been cleared out, and those high resolution pixels now are not appearing in the text. So there we go. That's the benefit of updating the ghost byte to introduce extra high resolution pixels, of black pixels anyway. It's either transparent or it's black, generally speaking. I mean, so in this demo anyway, that's the only place where it's used, is inputting extra high definition black pixels. Right. If we go back into Vice ICU64 and we change it so that almost all of the pixels in the ghost byte are black, then there you go. You can see that we get these vertical columns of high resolution pixels, and that's because there is one transparent pixel. And there we go. I've set it back now, so it's all transparent on the ghost byte. It's also worth pointing out that the multicolor sprite data is actually updated into the software scrolled text inside the sprites for the bottom sprite text effect. So I've got this demo paused at the moment, but pay close attention to this area here in the sprite debug data view. So when the particular frames of those sprites move down from the top to the bottom and obscure the apparently but not really high resolution text, then the multicolor pixels are inserted into the sprite data. So that's how we're able to superimpose what looks like multicolor pixels over the top of high resolution pixels dynamically, just by dynamically updating the sprite data. It's a really nice effect. It does mean that there's a lot of calculation going on in the background because it needs to mask the multicolor sprite data over the top of what it looks like high resolution character data. But that's part and parcel of trying all of these different techniques to add to the layers of smoke and mirrors to try and fool the viewer into thinking that they're viewing something when, technically speaking, actually they're not. Oh yes, let's see if we can find those sprite frames in ICU64 in the debug view. There we go. So we've got the different sprite frames for the vertically moving X, and there we are. Look, we can see all of the pre-computed sprite frames for the C and the O next to each other, the V and the A, or the A and the V rather, and the T and the E next to each other. So we can see all of those pre-computed sprite frames. We can see how they get wider and narrower with respect to each other. We can see, look, the horizontal timing for the color change for that sprite there. That's what produces that. But let's step ahead now to where the sprites get narrower. So let's take a screenshot when they are quite wide and quite far apart from each other, right? And they are necessarily far apart. Now, when the demo gets to this point, this is what I mean, is that in the 9 demo, when they were narrower, all of the 9 inverted commas sprites had their own individual coloring. Whereas in this demo, when they get narrower and bunched up, the sprites don't have their own individual coloring maintained. They double up on the coloring. So the sprites where, say, for example, you have the T and the E next to each other, when it's like this now, they don't have their individual colors. They have the same color. And that's because the timing for the vertical color split probably was too narrow to introduce these color changes, right, at specific points. So they just probably just chose to hide this effect by rapidly contracting and rapidly expanding again. So hopefully you wouldn't notice, but when we can step the frames, we notice. And that's why I say that this demo is perhaps not as technically advanced for the top portion of the screen as the 9 demo or my 10 demo, because the individual sprites don't maintain their individual apparently, but not really, individual coloring by using precisely timed vertical splits, if you like. When they get wider again, of course, the individual color changes for these horizontally expanded sprites then get reintroduced. But at some point, right? So when they're quite narrow and overlapping, then of course those sprites, they're the same color, right? When they should be individual colors. It's all smoke and mirrors at the end of the day. So yes, if you like these kind of technical deep dive videos, then please do consider liking or subscribing to this channel, or sending me a super thanks. They are always very much appreciated. Take care, have a great day, evening or night, wherever you are.